So what I'm going to do here is I'm going to start off with a file. It's a helmet. It's a bicycle helmet, and we're going to be doing the trimming of this thermoform part. And this can apply to trimming. It can apply to milling, welding, any type of robotic application which is process driven. So the first step is you bring in the CAD model. This is the CAD model, and this is the part that we want to trim. And the first thing that we do is we have a way of automatically detecting all the edges that need to be trimmed or welded and generate the paths. So therefore, we see here with one click of a button, we're able to determine all the areas that need to be cut, and we can create paths for those. This is huge because typically all these have to be meticulously done by a programmer, and you go and select edges, and sometimes the edges don't intersect. Therefore, we take care of all that. We have years of research in this. We can automatically generate all these paths effectively. Now, once the paths are done, and you're going to excuse me, I'm a little bit slow because when I record on my screen, things slow down significantly. The next step is we want to go in the robotic environment. So therefore, we're loading our new Rise environment, and this is what we've been talking a lot about. What's interesting here is you can see the robot, you can see the part, and you can play the path. However, it's a lot more than a basic robot simulator. One of the things that we can do is we can go ahead and do a reach study. So I'll go here and change views. I'll come here to the side. Now we can come and grab this part and we can move it right out. Now what's interesting to note is any time that we move the part, we click a button called calculate. Now we can see what parts of the toolpath are out of the workspace of the robot and what is not. Now in this case we have two operations. I'll put both of them on. We see the red X marks, so it tells us that we have areas that are out of reach. Now what's really interesting about our new environment is that it's interactive. So therefore, what we can do now is I can go ahead and interact with this part. I can go ahead and rotate the part, etc. Now what I can do is in this case here we see that there's areas that are out of the reach of the robot. I'll go to the farthest point. I'll click on this point here, and we see that the tool comes and connects to this point. Now the robot obviously can't reach it, but what's the fun part is now I grab the part and I start moving it in. Now as the robot is able to get to that point, it connects back to the tool. So you see at about this point here it connects back. I'll go back a little bit more, and then I'll click on calculate, and now we see that both operations, operation 1 and 2, are definitely reachable. So therefore, if we go ahead and simulate, we see that the robot can fully reach all the points. Now this is huge. This would typically take hours of work about a year ago. However, with this new environment, it's full interactive, and there's a dynamic reporting that is done to tell you, if there's a problem, where's the problem, and how can you effectively and graphically solve the problem. Now we do have another problem in operation 1, and we see here that when we put the mouse over the problem icon, that there's a singularity. Of course, singularity, reach, joint limits, over travel, these are all words that are very frustrating to a robot programmer. However, what is a feature that is very, very technological, if you will, for lack of a better term, in robotmaster is our famous optimization tool. Now we go to our first operation. I'll click on the robotmaster settings button. This screen here is what we call our miracle screen, where this path here shows, or this line here shows our path, and this screen shows all the errors that are possible. So you can map singularity, wrist flips, over travel, joint limits, out of reach, and you can even calculate collisions on the fly. And we see here at this point that we have an over travel, a singularity. So all I need to do is I take my path and I just bend it around the errors. And we see in this case here that we have a very narrow band of opportunity because we have a singularity here, we have some reach issues here, and really for this path to work, there's really only one way up this way or another way down this way. And sometimes, if you don't know, if you don't have this map, it is very difficult to know, because you go a little bit one way and then you avoid a problem and then you run into another problem. So this visualization tool, or what we call our optimization tool, helps you to effectively solve the problem. And with one click of a mouse, I have successfully optimized a 784 point program. This would have taken hours on the shop floor. Once everything is optimized, the part is in the proper place, then what we do is generate the robot code. In this case, it's an ABB robot. We support many brands of robots. And you have your code output, and this code output gets downloaded, this program file gets downloaded straight into the robot, and then you can run the part. What's interesting about RobotMaster is that we have a full kinematic engine that's plugged into the code generator. Therefore, what you get in the code is exactly what the robot will output. Zero manual editing. A lot of people today using offline programming packages have to do a lot of tedious manual intervention. All that can be avoided with RobotMaster. Thank you very much for this opportunity. It is very much appreciated.